So back in June, Guavus announced an NWDAF product called 5G IQ NWDAF, and at the same time, Guavus announced that that product would run on AWS. So what I'm going to do is ask Andrew to talk about that on this slide, and then I'm going to ask Guy and Naresh to talk about a little more what's going on under the hood here in the regional data center and the remote sites. So
this
go
is
ahead, Andrew.
A representation of how we're enabled to do that. We've divided up the NWDAF capability, the product that as Stephen mentioned, we call 5G IQ NWDAF. There's an edge module and a core module. And the core module is responsible for central storage, for model operations, for the 3GPP registration interface types of functions. And the edge module is responsible for data collection and local data scoring. Now, with this kind of flexibility that the pure NF environment and the AWS cloud environment allows for us, we can run the edge and the core module co-resident, if that makes sense. And we can take that edge module and push it out to really far remote sites where there are remote operations that are producing the data. Shown here, like examples for the UPF. That's one of the network functions that we expect to be generating a lot of this data. And it doesn't always make sense. We don't want to bring all of this data back to the core to be processed. It makes a lot more sense to do it remotely where it's generated. We can do it, and we can reduce the data size by doing that, and that reduces network transmission as well as storage and all kinds of requirements in the core. So being able to do that with this kind of flexibility, not only in a deployment scenario, but for even us, for our development environment, where we're confident that what we develop works across all of these platforms, provides a tremendous value.
Yeah, absolutely. So as Andrew mentioned, what we were thinking about doing here is firstly deploying the Guavus NWDAF solution first in the AWS region, as you can see here in the picture. And essentially the solution is completely based on Kubernetes. We are hosting it on Amazon EKS. EKS stands for Elastic Kubernetes Service. So essentially the concept here was to see how we can architect the solution across multiple availability zones to make sure that we are fully highly available. We are also using other services such as DocumentDB because we wanted to select a data store that will enable low latency in terms of storing the data and accessing the data. But we are also using Kinesis data stream, and the reason why we're using Kinesis data stream is because we wanted to stream the data from the edge to the AWS region, right? Because we want to cater for real-time use cases. So this is the central module. You can see obviously the different components. As I mentioned, everything was deployed on the EKS stack as well, and it's architected across different multiple availability zones. Absolutely. So in the edge, we were working with the Guavus folks, and the idea is to see what we can, what components are critical here, whether it will be the data collection manager, SQL stream containers, but also the prediction job. So we wanted to host on Outpost the prediction capability. So we will train the prediction model on the AWS region, but we will host the actual inference for those low latency use case for the prediction endpoint on Outpost. So that was the key here. We also use a load balancer, so the traffic is basically coming in, and one of the advantages here in the 5G architecture, everything is REST-based, HTTP2. So we just receive the traffic directly from the different network elements that you can see on the left side.